Very good evening, guys. How are you doing? Am I audible?
Good evening, sir.
We just started in a minute. All right. Yesterday we had studied the types of the TXVs. We had talked about the electronic EXV, about the EEV, sorry, the electronic what you call expansion wall. तो उसके ना दूसरे टाइप्स आप नोट कर लीजिए. We won't discuss them because they are not for much large systems. Number of mechanisms is developed to control the refrigerant flow electric valves. Electronic controlled valves sense the evaporator saturation temperature and its suction line temperature using thermistors. Basically, thermistor is, you know what a thermistor is, basically a RTD. Thermistor device changes resistance when the temperature changes, resistant temperature changes. Thermistors are wired to electronic control that controls the operation of the valves. One advantage of using electronic temperature sensing is being able to have the valve and the temperature sensing device in different positions. Means you need not have the EEV right there inside the near the room. Because पहले आपका क्या था कि when you had the bulb, okay, the bulb had the requirement that it needs to be nearby the wall. तो वो यहाँ भी wall need to be nearby. These walls are controlled by electronic signals, but the mechanism used are different from other types. So the what are main type? Pulse width modulating solenoid valves, magnetically controlled analog valves, heat motor valves, and stepper motor valves. The most common we saw yesterday, stepper motor. The other ones are also there, but I don't want to get into it because it will become a little bit too much involved. Okay, just note the names: pulse width modulated solenoid, magnetically controlled analog, heat motor, and stepper motor. Basically, there are different types. Now, the last part of the metering devices are fluid operated precision control valves. We've got two: low side float and high side float. We just discuss both of them fast. The metering devices discussed so far regulate the flow of refrigerant into the evaporator based on temperature and pressure. Like as you saw, the temperature is directly sensed or indirectly sensed, or the temperature is sensing and the pressure is changing that way. Another class of metering devices regulate the refrigerant flow based on the quantity of the liquid refrigerant at different places in the system. That means system is made such that you can sense the refrigerant in the liquid state. This approach to refrigerant metering requires a liquid receiver, a tank built into the evaporator, or a condenser where the liquid refrigerant accumulates, a float, a valve, and a linkage between the fluid and the valve. Basically, to make a hinge type of a linkage. There are two main types of fluid operated metering devices. The first type controls the flow of the liquid refrigerant to the evaporator. This type is called the low side float. The second type controls the flow of the liquid refrigerant out to the liquid receiver on the high side of the system. This is called a high side flow. So, a low side float LSF is an efficient yet simple refrigerant control. Its job is to maintain a constant level of liquid refrigerant in the evaporator. It does this by adjusting flow through its valve based on the level of the refrigerant in the evaporator. Basically, कितना evaporator में refrigerant है, उसके बेस में वो आपका वो control चलता है. Systems use this type of valve control and known as flooded systems. So only the one which have got the flooded system can be used for this fluid operations. The flooded evaporators used in the low side flow system are efficient heat transfer devices. This means that the heat moves easily from evaporator shell to liquid refrigerant inside. In this type of system, the liquid refrigerant flows from the receiver to the liquid line refrigerant, and flow is metered, means controlled by a low side float needle. So the fluid is controlling a needle valve basically. The evaporator in the system consists of a finned tank, okay, and a tank contains the fluid and a needle control. These maintain a constant level of liquid refrigerant under the low pressure side. This refrigerant, since it is a liquid, is in low pressure and at low temperature. The cold liquid refrigerant will absorb the considerable heat in both the on and off cycles. This is how the system looks like. For the condenser, the receiver, the liquid receiver, we can dryer, and the evaporator. So evaporator has got now this is the low side float because it is having a on the low side. And it got a needle wall basically as the float moves up and down, the needle wall will open and close and regulate the flow to the outlet to the receiver. So basically this is the device which creates the pressure difference. Note the motor controller mounted on the suction line. तो एक section line के ऊपर आपका motor controller भी है. So some of the refrigerant inside the evaporator tank vaporizes as warm air passes through the evaporator. The vaporized refrigerant moves to the suction line of the compressor. As this happens, the liquid level in the evaporator tank drops and the float drops. The float opens. As the float drops, the linkage between the float and the needle wall causes the needle wall to further open. This increases the flow of the liquid refrigerant to the evaporator until the proper liquid level is reached. Means जब तक वो balancing out नहीं होता वापस वो flow होता है. As the float rises with the new liquid level, it closes the needle wall. जैसे नया आ गया, इसके अंदर वापस आ जाएगा, तो ये all needle वापस बंद हो जाएगा. So means it's a constant system. Okay. The needle wall is slowing the flow of the refrigerant in the evaporator and maintaining a desired level. Okay. The operation continues until the preset pressure is reached and the motor control cuts off the power to the compressor motor. That means at that time the pressure will cut off the power. Now, the pressure on the low side of the flooded system is such as this will vary with the temperature. The higher the temperature, the higher the low side pressure. For this reason, such systems usually use low side pressure controls for the compressor motor. That means starting stopping of the motor will be controlled by the low pressure side. A spring-loaded pressure sensing switch is located in the suction line of the evaporator. When the low side pressure rises, the switch closes, activates the compressor motor, and as the motor drives the compressor, the pressure and the temperature in the evaporator are reduced. At a given pressure setting, the pressure switch drops. Means the pressure वापस खुल जाएगा, and the compressor motor stops. Means the contactor is open. When the pressure in the evaporator rises to a level corresponding to the preset refrigerant temperature, the cycle will repeat. Means again it will open, again the fluid will open, and it will start up. The compressor motor will then start again, and the cabinet temperature will be controlled by the temperature control switch. In such a systems, the temperature sensitive element is usually clamped to the fins of the evaporator. Like you see this evaporator के ऊपर यहाँ पे fins लगा है. Okay. It's often used on drinking fountain and other systems that are required to maintain constant temperature. Okay. Not much we want to go into it, but this is the idea. You see, you've got a float wall, you've got a needle sheet, and you've got a liquid injection line connection on it. Okay. This is the entire thing. We don't want to go much into this entire. Idea क्या है, एक float है, it's controlling a needle wall which opens the liquid line. Similarly, you got a different design. Instead of a float, like a wall float is there, you can have a bucket float. So bucket float is there, and you have got this bucket float which is there, a pan float, so not a bucket float. Okay, and then from here you have got the suction line, and you have the suction line going out, and this is a float here. Instead of a float, you have got a pan. Now, high side float basically is a similar thing, but on the higher side. The high side float is a float metering device that regulates the refrigerant flow to the evaporator based on the volume of the refrigerant in the high side receiver. A typical high side float refrigerant control consists of a chamber, the entire chamber, a float, wall, and a lever connecting the float and the wall, basically everything together. The floats are made either out of copper or steel, this thing, and the hermetic units. In hermetic units, steel is usually used. Needles and seats are made of a long wearing alloys, so stainless steel or hard surface alloys. A system equipped with high side float will not have a separate liquid receiver. The function of the liquid receiver is accomplished मतलब फ्लूइड चेंज, मतलब यही लिक्विड रिसीवर का काम है। तो यहाँ पे आपका आ जाएगा लिक्विड, and it will work as a liquid receiver also. Like low side fluids, high side fluids are used in fluid systems. The evaporator in the fluid system has a reservoir that is filled with liquid nitrogen. In this drawing ahead, which is this diagram, the a compressor runs the refrigerant from the condenser flow to the high side fluid chamber. That means from here it starts running to the high side fluid chamber. Okay. यहाँ से आपका outlet में. And as the chamber fills, the float rises, opening the wall at the chamber outlet. जैसे ये chamber बढ़ता रहेगा, ये इसका float rise हो जाएगा. As you see this the ball will go up and it will open the high side float chamber. Now, when the liquid level inside the float chamber drops, okay, sorry, as the float fills, the float rises and the wall will outlet. This allows the more as the chamber fills, the float rises, opening the wall at the chamber outlet. This allows more refrigerant to flow to the control wall. When the liquid level inside the float chamber drops, the valve closes. Slowly, the flow of refrigerant is slowed down. The amount of the refrigerant allowed to pass to the float wall equals to the amount of refrigerant vaporized in the evaporator. मतलब वो proportional है. तो जितना उसका flow होगा, उतना ही आपका evaporation होगा in the evaporator. The high side float may be installed right next to the evaporator, so that the refrigerant leaving the wall directly enters the evaporator, or it may be installed at some distance from the evaporator, connected to the evaporator through a liquid line. मतलब separate line से भी connect हो सकता है, but generally it is always connected nearby. If the high side float is installed away from the evaporator, okay, the system must be designed to the refrigerant exiting the float wall under pressure. But means यहाँ पे still there should be a pressure on it if it is away from the evaporator. But generally it is near the evaporator. Evaporator से दूर है यहाँ पे, तो यहाँ पे थोड़ा pressure करती है, ठीक है, as in this diagram. Now, this prevents the refrigerant from vaporizing before it reaches the evaporator. That means additional wall or other restriction must be installed between liquid line and evaporator to provide a required pressure drop. As you see here, यहाँ पे weight wall लगा दिया additional. So this gives a required pressure drop from the entire thing that will prevent the thing from getting that because it is a little bit away from the evaporator. You don't want that. You want the pressure drop to be there. So there will be a little bit back pressure which is there. A capillary tube is frequently used in place of a standard liquid line, where a thinner tube can be used. If a larger liquid line is used, it should have a weight wall in the evaporator. I just know that. Generally, होना है एक weight wall की जगह पे एक capillary tube भी लगा सकते हैं. A weight wall is a simple wall consisting of a weighting needle and a adjustment spring and a wall seat and an inlet pole and outlet pole. So basically क्या है ये weight wall is basically heavy. So against only the flow of the refrigerant it will open. That is the idea. So the refrigerant pressure in a liquid tank must be overcome and the weight of the needle and the spring pressure in order to pass the evaporator. So basically वो उसको नीचे load करके रखता है. Only when the flow of air is sufficiently high, it will open and that is basically creating a pressure drop over, which is required. Because otherwise this has to be very near to the evaporator. The evaporator is under low pressure and therefore the tubing connection and the high side fluid and the evaporator should be insulated. That means obviously other you will be affected by your frosting and everything. Either a temperature or pressure motor control can be used to type of system. Means what is operating the motor basically. Pressure or temperature sensing. Motor control sensing element may be located in the refrigerated space as shown in figure. As you see here, the motor is basically controlled by this sensing element at the inlet outlet to the evaporator. So basically either a temperature or it can be there or the pressure can be. High side fluid is popular for commercial applications, high operating efficiency, like big chiller plants and everything. I have seen one reverse ship with this type of fluid system, like blooded system, where you have got a large screw compressors and very big what you call the reverse plants. So वहाँ पे because the entire flow was happening through the what you call a secondary what you call heat exchanger. यहाँ पे एक brine system भी था along with that, but there you had got this type of a fluid operated chamber. That's what I just discussed with you. So that is the different things. Now let's talk about that is about the high side flow side. I just wanted to talk about it. Generally इसका वाला कोई बात नहीं होता, but I just wanted to talk about it. Now let's talk about the different components which we have in the systems. Yes, yes. So the one component that is quite important is the oil separator. We'll just see that, and we'll go into other components. The oil separator is fitted in the compressor discharge line immediately after the compressor. It is fitted to remove as much as of the oil carried by the refrigerant as it leaves the compressor and return that oil to the compressor crankcase. How it works is that the refrigerant vapor flow is forced to suddenly change direction. Okay. And as the oil droplets are forced out to the bottom, like you see here, gas from compressor is coming and it rises up, it hits these plates, and the direction of flow is there. That's why the heavier of part, which is oil, falls down. Okay. The oil accumulates at the bottom of the separator until a float or similar control device is fitted in the quantity of oil. जैसे कि ये ज्यादा हो जाएगा तो ये float होके वापस दे देगा. The oil separator is like a compressor discharge pressure, okay, because the compressor crankcase में आता है. The oil separator is a compressor discharge pressure, and the crankcase is a compressor suction pressure. So the oil will flow to the compressor as required because यहाँ पे higher pressure है, यहाँ पे lower pressure है, तो it will automatically go back. A side glass is often incorporated to observe the return of the oil flow. The return oil is often directed towards the shaft seal as additional lubricant. The return oil will go to the shaft seal and it will basically lubricate additionally. Now there is another different design of the oil separator. We'll see that also. Now compressors are lubricated by oil. The oil is placed inside the compressor crankcase or housing. It is circulated to various compressor parts. In hermetically sealed system, the oil also lubricates the motor bearings, no, not in other type of compressors. When the compressor operates, a small amount of oil is pumped to the hot compressed vapor. A small amount of oil through the system does not harm the system. However, too much oil entering the condenser, metering device, evaporator, and filters interfere with the operation. Oil can be separated from refrigerator by producing an oil separator between the compressor, exhaust, and the condenser. The operation as such as shown in the figure is here. So you see, this is a different type of condenser. I want to show it to you. Instead of having the what you call baffles, here you have got the same thing, oil and lubricant coming here, and you have got a helix. Okay. So the oil has to travel this helical path. Sorry, the vapor has to travel this helical path. As it does, all the oil basically will fall and accumulate onto the helical, the lower side of the helix, and it will follow the slide, and it will basically come down and it will fall down. And down you have got again the oil returned by a float. So this is one more different design of an oil of a oil separator. जनरली तो वही एक डिजाइन है जो आपका जो बैफल वाला दूसरा अभी आजकल नया एक और नया डिजाइन. So the oil separator is a tank or a cylinder that contains a series of baffles or screens to collect oil. The oil is separated from the hot compressed vapor, drops to the bottom of the oil separator. A fluid controls the needle valve and oil returns to the crankcase. When the oil level is high enough, the float rises, opens the needle valve, and the pressure in the oil separator is considerably higher than the pressure in the compressor crankcase. This causes the oil to return quickly to the crankcase. The oil serves as a liquid seal to prevent refrigerant from entering the liquid return lines. ये भी एक आपका addition हो गया. Oil serves as a liquid seal to prevent refrigerant from entering the return line. The float closes the needle valve when the oil level in the separator drops. Oil separators are quite efficient. They allow very little oil to pass the rest of the system. Oil separators are most commonly used in large commercial installations. Now, yesterday I had not shown you an internally equalized TX2. This is a photograph for internally equalized and an externally equalized. Forget this push rod, which is a older design. आजकल push rod नहीं होता, वो spring है और diaphragm है. But idea क्या है कि underside of the diaphragm is getting the internal equalization from directly from the outlet pressure. ठीक है. और ये external equalization है जो आपने देखा. Okay. The idea is both the suction line pressure is going directly at the bottom of the diaphragm. Okay. ये आपका पुराना टाइप का है जो आपका पुश रॉड टाइप का एक्टिवेटेड है, बट आजकल ये पुश रॉड नहीं होता, देयर इज अ बेसिकली मीडियम वॉल्व रॉड. Now, about the bulb location, I also said that I'll find out a little bit more. So here, the something cell should never be repeated on the bottom of suction line. We had seen this yesterday. Liquid or oil can puddle at the bottom of the affected temperature, but the bulb is normally mounted at 4 or 8 o'clock positions on suction lines that are 7, 8 inch OD and larger, and the bulb will be mounted anywhere except the bottom of the lines which are 7, 8 in inches OD. That means अगर 7, 8 inches से smaller है, so anywhere except the bottom, otherwise it can be there, but anywhere it can be at 4 o'clock or 8 o'clock positions. Means if you make a circle, then anywhere at the 4 o'clock position or 8 o'clock position, it may be there. When the larger lines are there, but smaller lines anywhere except the bottom. If a vertical bulb installation cannot be avoided, the bulb may be installed on a descending vertical line, as you saw yesterday, with a capillary tube end at the top. The bulb should never be located in a trap downstream of a trap. मतलब आपका वो भी trap के नीचे नहीं होना चाहिए. The liquid collecting at the trap can throw the temperature reading at good point. Okay. Good thermal contact extension in the wall of operation. The bulb should be fastened to the line with copper strap as we saw. It will not only hold the bulb securely but also help improve the thermal contact between line of the bulb. Finally, the bulb should be situated insulated from the surrounding air so that the temperature of the bulb is sensing and it does not air should not alter the sensing temperature. Now let us look at the condenser. The condenser may be of the water-cooled plate type, but it is difficult to seal and clean and service. Most usually it will be a water-cooled shell and tube type. Generally, shell and tube type का ही condenser होता है. Okay. And mainly because it is easier to keep gas tight and the cooling water side to be cleaned without danger of leaking the refrigerant. The cooling water on the modern marine systems will be part of the central cooling system, but seawater cooling is often seen used. I've seen some refrigeration systems which have got separate seawater systems also, like large research plants or something. Okay, it's not central cooling. Central cooling for the engine and everything, but this was having still refrigeration or having the cooling seawater. On some plants, the cooling water flow is controlled by thermostatic valve, which will control the precise level of the undercooling of the refrigerant in the condenser. Condensers will be fitted with relief valves, which will vent any overpressure of the refrigerant should the high pressure cutoff fail and the cooling medium also fails. On land-based installations, cooling water is often circulated to cooling tower. हमारे यहाँ पे नहीं होता cooling tower. However, this is becoming less popular due to danger of Legionnaires disease. Legionnaires disease is basically air gets infected by bacteria in the air. In the absence of an available cost-effective source of cooling water, air is often used as a cooling medium in the condenser. This unit will include a fan to circulate the air to the cooling fins to the condenser. This will require frequent maintenance and ensure that the fins maintain clear of debris. मतलब ये air type का भी आपका ये condenser नहीं होता है because this is generally there in your smaller what do you call container type के आपके जो refrigeration system होता है उसमें हो सकता है air type condenser. Generally, you always have the water cooled condenser. Just give me a second. Okay. Shell and tube type condensers. Where the medium is to be cooled in the evaporator as brine, okay, the design of the evaporator generally follows the lines of the condenser. With this type of evaporator, the brine is usually exchanged to pass through tubes and the refrigerant contained in the shell. Okay. The area of the tube surface in contact with the refrigerant determines the performance, and the present trend is to submerge all the tubes in the boiling liquid. Basically, as all the tubes should be there inside the liquid, which is the refrigerant liquid. Okay. This involves either a high level liquid in the shell or placing the tubes in the lower part of the shell only or the upper part. When forming the vapor chamber, the refrigerant level in the evaporator is too high, or if the evaporator is working at the limit to the capacity, and violent boiling of the refrigerant leads to carry over the liquid with the outgoing gas. So he's trying to say this is the type of the condenser where you've got either what you call seawater outlet and seawater inlet and refrigerant inlet and outlet is there. तो या तो ऐसा type of condenser होगा, second tube type का, and one more type is there. So this is generally there where you've got the the medium is pulling the brine. I think the one ship we had this brine was being pulled. ये उसकी बात कर रहा है. So basically there can be a carryover in that also because there is a very high rate of boiling water. Shell and tube evaporators may also be of the dry expansion type, which is in which the refrigerant passes through the tubes and brine is circulated through the shell. So the one is where it is the wet type, जहाँ पे आपका बाहर उल्टा होता है. That means the refrigerant is outside and the brine is inside. But there is one type where the dry type is there, where the refrigerant passes through the tubes and the brine is outside. To avoid liquid carryover, this type of thermometric evaporator, thermostatic regulators are used ताकि वो control करेगा. This type of evaporator has the advantage that the charge of the refrigerant is reduced and more positive return of the lubricating oil to the compressor. It means this type of your with जहाँ पे आपका refrigerant tubes के साथ है and brine through the shell. So this type of evaporator has the advantage that the charge of the refrigerant is reduced, means total volume of the refrigerant is reduced, and more positive return on the lubricating oil to the compressor. The disadvantage is that the brine passages are more tortuous and restrictions due to impurities of the brine is more likely. Okay. Thin walled steel tubes can be used in evaporators of this type, and with its construction is advisable to add a cover movement. Guys, what is brine exactly? What is the constituency of brine? It's no liquid of a known density, but generally it is a saline solution type of a liquid. Like it is salty in nature, and it can also be some. Nowadays, you're having brines which are not natural brines. Like you can have water-based brines. You can have also brines which are mixed with two, three different what you call like water-based only, but again with some other what you call chemicals added to it to aid the the heat transfer and everything. One can be just
So
simply
that glycol solution is also considered brine, right?
glycol is also considered brine because but then you require a huge volume of it. ठीक है इसका बहुत बड़ा आपको solution चाहिए होगा volume of it means but becomes a little bit more expensive because glycol, ethylene glycol is uh, more used as an antifreeze than actually as a brine. Because the situation is that it is quite expensive situation, I think, as it is. So you can have a saltwater brine, which is cheaper to make, but the problem with that is obviously corrosion and everything. So you have to have system that way. Then other thing is that you can have these chemical brines. You can have some specialty chemicals added to the water to render it, the anti-corrosive properties as well as enhance the, the what do you call, uh, the refrigeration effects will also be better. But generally, as I said, also ethylene glycol is also used. वो ethylene glycol आपने छोटे वाले सिस्टम में देखा होगा कोई like for large what do you call refrigerating holds over there. Where have you seen this ethylene glycol in the ship or somewhere?
No, usually I've seen it only in the cooling water systems, like anti-freezing element. Otherwise, for heat transfer, I've not seen anywhere being used.
In what you call older systems. Yeah, older systems में मतलब जहाज पे नहीं, but on the uh, this thing क्या बोलते हैं shore side. ठीक है, but ज़्यादा करके they have got salt water brines which are cheaper. ठीक है, to because see what is the situation is that one of my vessels, the reefer vessels, we had about uh, 12 hoods. Okay, 12 hoods, and not that big, but 12 different hoods, like four levels, three levels in each hood, and four of them. So all of them had got these brine, what do you call, coils. Okay, and the problem with the brine coil is when the vessel goes old, it starts leaking. Okay, and there we had got these salt water brines. तो ये मेरे को याद है उसमें उसमें बहुत ज्यादा प्रॉब्लम होता था एंड there was a particular density of the water being checked and everything. वहाँ पे एक ETO only was doing the work of the reefer engineer, and he was checking all this. And we used to basically, I was a long back, I was a cadet back then, so I was to go into the hold to clean these coils and everything. These brine coils, they're there inside each hold, and the brine is circulated through large what do you call screw type compressor in the what do you call this type of a shell and tube type of this thing, what do you call condenser. So, as I said, process is because of impurity, the brine is likely to basically get choked out. Thin welded tubes are can also use in evaporator type, and with this construction, you are able to add a corrosion inhibitor. As I said, corrosion inhibitor is added. Now another type is shell and coil type of evaporator. Condenser, evaporator and condenser. So shell and coil type evaporators are used with carbon dioxide and are of large multiple coil types. These coils are heavy gauge tube steel, and they have to be able to withstand the refrigerant pressure. And provided the brine is extracted at the right pH value, corrosion is not usually a problem with the evaporator. That means it takes care of the corrosion basically. Corrosion really attacks these units first at the coil end where these pass into the atmosphere. And to minimize this, it is a good practice to keep the coil ends well clean and lightly greased. मैं उसके ऊपर थोड़ा सा आप उसको ग्रीस लगा के दो ताकि उसके ऊपर ये नहीं है क्या बोलते हैं, ठीक है, corrosion. This type of condenser is usually of carbon dioxide owing to high pressure involved in the consists of coils and copper and aluminum brass piping in a steel copper shell. So the shell is steel and copper, and coils are of brass and copper. The cooling water passages over the outside the coils, and the refrigerant passes through the coils. So again, the refrigerant is inside the coil, so that there is no there is no carryover of the refrigerant. तो ये आपका कार्बन डाइऑक्साइड है. Carbon dioxide is not that used that much as a refrigerant nowadays anyways. Okay. Then shell and tube type. This type of condenser consists of an outer cylindrical shell, ends of which are closed by two tube plates. You see here. Okay. The shell is normally made out of steel or copper, and the tube plates of aluminum brass. The tube plates being connected to the shell by brazing or welding. Tubes of aluminum brass are secured between the tube plates by expanding them into the holes cut into the tube plates. मीन यहाँ पे ट्यूब प्लेट के अंदर एक्सपांड कर करके एक ट्यूब को जैसा आपने बॉयलर ट्यूब पर देखा ना एक्सपांशन करता है by the by that there have a what do you call expanding machine जिससे आपका जो एंड में उसको उसको फ्लेयर आउट करते हैं एक्सपांड करते हैं पहले पैरेलल एक्सपांड करके फ्लेयर आउट करते हैं सिमिलर टाइप ऑफ थिंग इज डन फॉर दिस टाइप ऑफ अरेंजमेंट so you got a tube which are added to the tube plate first, okay, and the cooling water passes through inside the tubes and the water boxes enclose the end of the tube. Like you see, this is the water boxes over there, okay. Make avoid with baffle plate so that the water makes two more passes. जैसे कि बीच में एक baffle डाल दिया तो एक और second pass दिया होता है before it actually go down. Okay. To keep the heat transfer coefficient in condenser up and thereby keep the size of the condenser down, it is usually to design for a water velocity in order 2.5 meters per second. This velocity is approaching the velocity at which erosion arises. If no automatic control is fitted to limit the water velocity, care should be taken that the rate of the water circulation is not allowed to exceed desired figure. मतलब 2.5 से मीटर से ज़्यादा नहीं जाना चाहिए. अगर आपका velocity बढ़ रहा है तो automation होना चाहिए to control the flow. Ammonia condensers are generally similar, but with the refrigerant shell, the tube plates and tubes are made out of steel. Ammonia attacks copper and iron. This is the problem. Okay, please give me a second now. Now, sometimes they ask what all and where all does the heat removal take place inside the condenser. Okay, so this is the answer for that. This is asked by I think so Pakrasi sir sometimes. Okay, where all is the heat removal taking place inside the condenser? So you see, this is your entire system. The pH, the scale, the diagram is there. pH diagram. Okay, so here you see approximately 15% heat removal occurs as superheated refrigerant vapor cools. Okay, and then approximately 80% heat removal occurs as the vapor is condensed in the condenser, and then approximately 5% heat removal occurs as the liquid refrigerant is subcooled. So that is initially before even entering the condenser, as the superheat refrigerated vapor cools, as it's approaching the inlet to the condenser, it starts, getting the enthalpy doesn't change, but the cooling starts. Okay, about 15% is there. Then maximum is 80% is during the cycle. Okay, as it is, losing its enthalpy. Okay, it basically changes its pressure and it changes its state. So 80% heat removal यहाँ पे होता है. And then remainder 5% is there. It is subcooling is with everything is subcooled and it leaves the condenser. This is a good explanation to show where exactly is the heat and where is the this thing. Now, compressor service source. Okay. So there is always note that whatever is the walls, okay, they are always what you call they never have generally don't have what you call on the service walls of the compressor, you won't have any. You have spindles, but you don't have the wall heads. Generally, they don't keep the wall heads so that nobody messes with them. और उसको निकाल के एक separately there will be a key or something will be kept somewhere extra. That means nobody can open it. And generally, all these wall heads have got a cap on top of it. So only when your cap is open, you will actually able to open the wall or close the wall. Okay. So and they're always back seating. Okay. The walls fitted to all but large compressors will have suction and discharge valves of the back seating type. This allows the wall glands and the service connections to be isolated from the main refrigerant flow. By the wall grid being able to seal on the top, means as the compressor goes into the back seat, it seals it, as well as a normal position. This helps by minimizing the possibility of refrigerant leak. So back seating means you see uh, this is the upper seat and the lower seat. As it is going down, it is going back. And that is the reason what they're saying is that it will basically minimize the risk of your leakage. Because you're closing it down, there is a way to close it. Here we put minimizing possibility of leakage because the back seat is there. Basically, the wall weight being able to seal on the top back seat as well as a normal position. So basically, दोनों साइड से seal करता है. Okay.
So, sir, this is the reason why these valves are supposed to be either fully shut or fully open, right?
Not
क्योंकि बीच वाली position में it might just start leaking from the gland, right?
उसमें डेफिनेटली बिकॉज वो फिर वो एक साइड पे लॉक नहीं हो जाएगा लाइक यू सी हियर इधर इट इज अप और डाउन ठीक है तो बीच में अगर
Yes,
आप
sir.
बटन नहीं कर सकते उसका ठीक है तो इधर फुल्ली
Okay.
ओपन फुल्ली शट ठीक है वही बोल रहा है सो इट हैज टू मिनिमाइजिंग द पॉसिबिलिटी ऑफ रेफ्रिजरेंट लीक थ्रू द वॉल जॉइंट बिकॉज नॉर्मल पोजीशन में इधर वन साइड पे ऊपर रहेगा या फुल्ली डाउन होगा तो वो बैक सीटिंग की वजह से वो ग्लैंड की तो लीकेज नहीं होगा ठीक है एंड ऑल्सो फैसिलिटेट्स द कनेक्शन ऑफ सर्विस गेजेस while the plant is in operation so means you can connect whatever service gauges तो आपका जो एक 3 gauge वाला कनेक्शन होता है वो वाला तो ऑयल चार्जिंग whatever you want to that can be the walls always do not have hand wheel so that the ceiling cap may be fitted if you see this is a ceiling cap on top say it is important that the cap is always refitted after service to minimize possibility of refrigerant leaks to environment. Again, if the gland seal is leaking, it is basically always having the cap in the position and it is usually tightened in position. It is that way. So it is important to that the cap is always refitted after service to minimize possibility of refrigerant leaks to environment. If a service engineer cannot be bothered to replace the cap, it is very clear indication of incompetence. अगर कोई पूछता है कि just cap लगा के कुछ होता नहीं. So you have to understand that cap is also gas tank. A special square ratchet tool should be provided to the service toolkit to minimize damage to the wall spindle while operating these valves. So basically एक hexagon एक square का एक आपका ratchet tool होता है. तो आप देखो छोटा सा एक होता है जहाज पे. तो उससे इसको open करते. If you do not have the key, special key for this. Normally there is a slot key also available. If that is not there, it's best to use it one ratcheting tool available for opening and closing the valves. And it is a standardized tool. Okay. Uh, the service connection will also be capped. These are normally 1/4 flare connections but with a refrigerant with a particular high condensing pressure is in use, such as R4108, then European regulation states the service connection will be half UNF, means a different thread should be there. That only the high pressure rated service tools can be connected. मतलब वो fine thread, basically half UNF is another fine thread in the normal thread. वो fine thread होना चाहिए. In large compressor, service valve will be fitted for connection in the service tools. However, the main suction and discharge valve is specially designed to minimize the leakage of the refrigerant and size according to the pipe dimensions. Now, along with the service valves, there is something called the king valve. I'll just show you what that is. Just sort of got a better diagram of this back-seated valve. I'll just show you. So you see, this is a service wall, and I will show you five positions where this is the back seated. This is a better view of the diagram wall. Okay, so the service wall is one of these types of access points for the refrigerant side of the system. They can be located on the compressors, receivers, accessories, as well as located inline on the piping. They allow a mechanic to perform tests from go down the installations. The diagram below shows a close look on how the service wall works. So basically, this is not a live view, so I'll show you different options. So one is the back seat that you see here right now. This is a back seat and this is the front seat. The two seats हैं and ये आपका wall के ऊपर दोनों angle. So the access port is closed, like this access port is closed. The service wall caps up in place, like the cap ऊपर को place है, ये वाला cap in place है. This is the first position. Give me 1 second. All right. As you see, this one position was where the back seating is occurred, where the wall is completely shut. Okay. Now what happens is number two position. Okay, it is cracked off. Okay, that means you've connected a service hose and access port is open and you've cracked open. If the access port is open, it is okay for reading the operation pressure. Means थोड़ा सा इसको क्रैक कर दो ओपन और फिर आप उसका प्रेशर देख सकते हो व्हाट इज द आईडी सर्विस में लगा के ठीक है वो उससे प्रेशर गेज लगा कि कितना प्रेशर एंड एवरीथिंग उसके लिए 1-2 सेकंड के लिए ठीक है क्रैक ऑफ ओपन करके और फिर बंद करके सी द व्हाट इज द प्रेशर ठीक है सो दैट इज आइडिया नेक्स्ट थिंग you can if you want to evacuate the entire thing okay you want to evacuate the entire system कि आपको पूरा pump down करना है or something like that so now you open it mid seat okay so best position for evacuation all chambers are open as possible this is the compressor this is to the access port to the service hose and this is from the piping Normally ऐसा था, अभी आपने खोल दिया and everything is open for the chamber to be open. That is also possible. Then next position is that here you have basically position number 4 is, so you see position number 4 is this, that it is cracked off, okay, the front seat. Now this is used for test throttling the refrigerant flow to the suction service valve. तो बेसिकली अगर आपको टेस्ट थ्रॉटल करना, यू वांट टू सी सक्शन सर्विस वॉल्व के ऊपर बेसिकली कितना आपका फ्लो जा रहा है, टेस्ट करने के लिए, तो एट दैट टाइम जस्ट यू जस्ट ओपन इट एंड यू ट्रैक इट. So this is just for testing methods. Okay. And then finally, this is the other position with the front seating. Okay. So for good compressor pump down efficiency, you can do this with the test. Okay. Do not front seat the wall. Okay. And when it, and then run the compressor. Basically, front seat रखोगे तो वो run नहीं करना चाहिए. This would immediately create an extremely dangerous condition, and the discharge gas would have nowhere to go. So ये अभी and front seating king wall will cause the igniter pump down. ये अभी आपका service wall. Now what is the pump king wall? I'll just show you. Just give me a minute. King wall I'll show you when I talk about the charging of the refrigerant. ना उसके अंदर examples दिया हुआ है. Now we'll just see the other walls which are also there. ठीक है, just give me a second. So other wall type is called as Schrader walls. The Schrader wall is very common and comes with a great number of variations. This is a depressible core. Like you see, there's a needle wall on top, like you see in tire walls. The service hoses come with a depressor to suit. मतलब basically जो service hose लगेगा उसके अंदर इसका depressor लगेगा, and then you connect it, so automatically this is like a like a non-return valve. The swivel acts as a T. Basically, यहाँ पे you got a swivel connection, then you got a T connection, are handy for creating a second access port to a service valve location for control sensing line, which will leave a service port available. Many systems have shader valves and no service valves. Shader valves are better, मतलब उसके अंदर आपको कोई don't have to worry about the wall leaking. तो this gap खोल दिया तो the valve in a shut position. ठीक है? So there's no need for any functionality of the service valve. If you go ढक्कन खोल दिया, it is not start leaking. Okay. However, it is possible to install a shader valve anywhere in the system. The cores of the shader valve are replaceable, and if they fail to see it properly, offer a new core will stop the leak. तो एक नया core भी मिल जाता है. The other type of valve is this line tap valves. Okay. So line tap valves are known as saddle valves, as you see them. and they are piercing walls. मतलब you see एक पाइप जा रहा है तो उसके ऊपर ये वॉल को लगा दिया और कंप्रेस कर दिया, ठीक है, and be very handy for accessing otherwise unavailable sections of seed system. They are only way to obtain access to a pressurized system which was factory charged through the process of tube. ट्रिम टॉप मतलब बेसिकली ट्यूब के बीच में आपने वो बिल्डिंग लगा दिया है एंड टू एंड एंड देयर इज नो फ्लैंज कनेक्शन टू कनेक्ट दी वॉल, तो ये लगा दो आपको लाइन टैप वॉल दो हाफ में है इसके, ठीक है, इट इज गॉट अ पियर्सिंग नोजल and you connect it and as you clamp it it will basically make a gas tight seal and also make the hole and then you've got a shader wall on top of it, okay, so line tap wall is better because you don't have to worry about where you do not have any service line, okay. Sometimes your this thing on survey will ask you like you want to what do you call charge the system with oil or you do not have some charging connection on the high side or on the low side. So kaise karoge? So this is one option you have. You can make a permanent connection like this. You can modify the system because your line is there. You have to cut it. You have to then depressurize the system. You have to use it. तो ये क्या है आपका during the what do you call operational system only you can make it the entire thing. Okay, you do not need to depressurize the entire thing. The line come with two halves which can be placed around the active section of the refrigerant priming and locked in place with iron screws. Okay. A depressor pin is temporarily inserted and cranked down with a valve cap. Okay, and this places the pipe. And when the pin is removed, the needle retracts, giving a sealed access. It is accessible by depressor shader valve. मतलब इसके अंदर opposite shader valve. तो initially there is a इसको clockwise घुमाओगे इसके ऊपर तो उसका एक जाके depressor पिन जाता है नीचे, ठीक है. The seal relies on a rubber ring that can be it can be advised to install this type of access valve on a hard discharge line. So hard discharge line पे नहीं रहना चाहिए. तो rubber o-ring तो आपका leak हो जाए. It's best to use them only when there is no other choice. At a time when it is inconvenient, it should be replaced with a more secure welding in place service. I mean, best is to weld it, but वो नहीं है तो उसकी जगह पे ये टाइमिंग के लिए लगा सकते हैं. 9 tap balls. Now, yes, sir. All right. Liquid receiver. Most refrigerant systems use a shell and tube condenser. This will seize the condenser to allow the refrigerant charge to be stored in it when pumped down for maintenance. Okay. Or during normal cycle when the room temperature is cold enough and the liquid line sewer line was closed. Okay. A side class will be incorporated to observe the running and pumping down of the refrigerant levels. If the condenser is of sufficient capacity, or in case of the air-cooled condenser, a liquid receiver will be incorporated in the system. Just after the condenser, in both cases, a circuit isolating valve will be fitted in the outer of the liquid receiver condenser. In the registration above, the liquid receiver can be seen underneath the air-cooled condenser unit. You see, this is a large external air condenser, what do you call, condenser for a system. Mostly a shore system, but you see right here, you've got a liquid receiver below. Okay. The liquid receiver is required for larger system, and where you got a this thing. So this is your liquid line side glass. Okay. These are fitted on the liquid line after the condenser. They are used to give the indication of the system refrigerant charge. Bubbles of vapor in the side glass will indicate an undercharge. So basically, you have to look for bubbles. They normally also include moisture indicator where you change color to the moisture difference. You see here, if the entire this thing, the bulb in the center, we change the color, it will say it is this here. You see blue with blue means good. Okay. If moisture comes, it might be turn red or orange. I don't know why the other color is there. I can't read it in this. But blue with blue, I remember was good. Otherwise, you had got red was red, moisture was there inside the side. Then liquid line filter dryer. These are inline filters including a drying agent, silica gel or activated alumina, sized to suit the system and pipe dimensions. Normally they are sealed replaceable units. However, are some that may be dismantled to replace the cement core element block. They may have soldered or flare threaded connections. या तो डायरेक्ट कनेक्शन होता है सोल्डर्ड कनेक्शन या थ्रेड कनेक्शन होता है ठीक है अगर सोल्डर्ड कनेक्शन होगा तो ऑब्वियसली आपको उसको फिर कट करके पूरा का पूरा नया रिप्लेस करना पड़ेगा लाइन to the dryer. They are normally fitted with a bypass system so that the plant can be operated while the filter dryer is being changed or maintained. Okay, some installations, particularly using semi-hermetic compressors, will have a suction line replaceable core filter immediately after before the compressor. They are usually left empty and a filter core will only be inserted during commissioning. देखो उसके commissioning के time पे रहेगा बाद में आपका एक core निकाल दो ठीक है will not required. Or when cleaning the system. Means if you want to clean the system after a maintenance something, you know, like a burn of the electric motor in that hermetic design. Different cores are available for acid or moisture removal. तो उसके लिए भी आपको एक core आएगा, ठीक है? This is the type which is there. This is the replaceable type, which is the filtered wire. This is the seal type. Seal type ये रहेगा तो ये आपको पूरा का पूरा ये change नहीं कर सकते, इसको आपको replace करना पड़ेगा. Otherwise, this is the one which can open and change the core of it. Now, solenoid valves and thermostat. Okay. Solenoid valves, shut-off valves are fitted before the expansion valves and are usually used to control the flow of refrigerant through the expansion valves. They will be controlled by a thermostat in the room being served at the expansion valve. By this, it means it is possible to control a number of different rooms at different temperatures from the same refrigerant system. They should also close when the refrigerator is compressor is stopped, thus ensuring the evaporator is not filled with liquid refrigerant, which might get transferred to the compressor section when the plant is started. तो ऐसा डिजाइन होता है एक आपका सोलेनोइड वॉल्व है बीच में टी पीस which is basically a magnetic head and the sleeve is sealing the entire thing and then you got the wall which is spring loaded and the wall is basically opening and closing against the refrigerant flow. ठीक है तो कंडेंसर से आता है evaporator में and basically it goes that way. If you want to open it, so basically sensing के हिसाब से it will open it is required, otherwise it is going to close. Just give me a second. Just hold on a second, guys. Acha, the outlet of the thermostatic expansion valve bulb, okay, is supposed to be 150 to 200 millimeters away from the equalizing connection. That means equalizing connection is to be towards the compressor after the evaporator, okay, and up to 150 to 200 millimeter away from it. So that is the idea that that is the maximum requirement. I'll just show you the diagram which I got just now. I remember where it was. See something like this. Like here, you have got the expansion wall, and there is the equalizing connection. The equalizing connection से और आपके bulb के बीच में 150 to 200 millimeter maximum length होता है. And the angle at which the bulb is connected, I told you. But I remember there was some distance also, 150 to 200 millimeter maximum from the equalizing connection. So इसका there is a correlation to the pressure drop across the evaporator and the pressure drop if the distance is more from the thermal bulb and the sink. So there will be a difference in the calculation. So इसलिए 150 to 200 millimeter होता है. Okay. So this is the idea. Okay, why it is 150 to 200. Just give me a second. All right. The next wall is your back pressure wall. What is the purpose of back pressure wall? What is the purpose,
The
guys?
purpose is that any room which has attained its temperature
Huh.
uh, will be so there'll be I mean the expansion valve will stop the flow of the refrigerant to that particular room, right?
Okay.
So and at the same time the other rooms might still be getting the supply of refrigerant from their expansion valves. So this refrigerant from the other rooms should not come back to the one that is already attained its temperature.
Uh,
In that for that reason, back pressure valve is supplied.
uh, that is one of the ideas, but mainly it is to not see what happens. If you are just give me one second. I'll show you one diagram. Maybe it makes sense.
So that pressure and temperature should be maintained. For certain pressure, there will be certain temperature will be maintained by refrigerants. So for veg room, you need a lesser temperature. So you have to maintain low pressure in the veg room area. That one
Right.
chart will be there. So with respect to pressure, that temperature is maintained.
So you see this one idea where you have got evaporator of a meat room, a fish room, and a vegetable room. So all the three are going out, and all the three will be coming back. Okay. Now only this is the back pressure regulating valve in the outlet from the veg room. Okay. So see, what we are not concerned with the outlet of the meat room basically going out here. What we are concerned is the pressure drop in the inlet of the inlet of the compressor. Okay. Compressor के inlet पे you get lesser amount of flow because yes, amount of the refrigerant will go inside this line. Okay. But the purpose is not to prevent this thing from going here. Prevent it to because see the pressure basically will go to from high pressure to low pressure and it will take the least path. So it will go here. Well, I agree. But the purpose is not to prevent this backflow. The major purpose is to prevent that the refrigerant basically going to the inlet of the compressor, not basically going anywhere else. Okay, so that is one idea. And once again, I'll just share something. As you said, okay, the back pressure is fitted in multi-room refrigerant systems. They are fitted in suction return line from the evaporator. This ensures the desired temperature is maintained in each room and the pressure of the refrigerator is regulated temperature. If the pressure is allowed to go too low, this would reduce the temperature also. Okay. So similarly, meat room का -25 saturated temperature है, so veg room का +5. Okay. Suppose for ammonia, if you're utilizing, you've got different temperatures, and for R12, R this thing, and R134 ये. So that is the idea कि ये आपका जो veg room का है, it should not go below this +5, and for different saturated pressures उसके हो जाना चाहिए as per the saturated temperature. Okay, that is idea. So that is the main reason. Just give me, let me share one more thing also. Just give me a second. See, it is not that the veg room will go at a very low temperature. Yeah, that will happen. But before that, your inlet to the what do you call uh, your compressor, inlet to the compressor will get a very less pressure. Okay, because now the pressure will want to go into the least path of resistance, right? So that is the reason it will go there. Some people say that it will lead to the wedge room icing up and something like that. Okay, वो हो सकता है eventually, but before that your compressor will shut down. Okay, because now your compressor suction line will not get the same amount of the flow, because what is happening is now both the other veg room and meat room, they are veg room and fish room and veg room, they are getting the flow that is not normal. Okay, and the return line is going to go direct to a suction. Okay, तो वो क्या हो जाएगा now lesser flow will happen, and it will go back to this. I just show one more diagram of this concept. So you see this line. This is a block diagram showing the entire thing. So here you have got the in the handling room and the veg room, you have got the back pressure valve, and here you are going back to a system. Here you have got the meat. So suppose meat room has been at a lower temperature, the meat room will keep on going, and now you have when one of the two rooms are cut out. Okay, so the night valve will shut over here. Okay, and most probably at that time the capacity control will also operate to reduce the capacity of the compressor. Okay, so now only one room is operating. Now in this case, suppose the entire flow is going out only for meat room, and now suppose back pressure valve was not there. As you said, reverse flow will happen. Reverse flow will happen, but the main problem is why the reverse flow will happen is basically the pressure in this side will become less. Okay, and at that time you're not going to LP cut out, but obviously it will take more time to operate. That means uh, your your basically the shutdown of the system will not happen at the time. Okay, go here. It will not go back, and system will basically take more time to regulate this temperature. Similarly. And veg room में, as they say sometimes, some people say that freezing can occur. See, that will occur at a later time. Okay, uh, that is the idea. The main idea is that to prevent the change in the pressure over here. The pressure will change over here, and that is there. And let me show you how this thing looks like. This is what a back pressure regulating wall looks like actually. ठीक है? इसका जो assembly of you. There is a wall cage assembly with a spring inside, and the top seal is there assembled. And ये आपका at a particular pressure it will basically shut. ठीक है? इसलिए ये pressure दिए हुए हैं यहाँ पे. So you can adjust it as per the refrigerant. What pressure you want to adjust. So इसको ये cap को खोलते you can actually tighten this spring assembly, and it is going down. When the spring is going up or down, it will basically change the orientation. There is one more type of back pressure regulating valve which is solenoid operated also. I'll just show you that also. Just give me a second. So nowadays they don't have a separate room solenoid valve and a separate back pressure valve. They have it both in a combined what do you call body. I'll just show you how it looks. This is a back pressure regulation valve, okay, and a solenoid valve combined. So solenoid valve is there on one side, and this is the back pressure valve. Okay, so two temperature regulators plus solenoid valve. So ये आपका दो back pressure valves है और साथ में एक solenoid valve है. So that means you can also operate this. The room solenoid valve can also be controlled directly over here. So rather than have a separate control for the room solenoid valve, the room solenoid valve and the back pressure valve, they are in one complete housing. So one side, left side is doing uh, the shutting down function, and the right side is doing the back pressure function. Okay, that is the idea. So all on a controlled, what you call combined one. Okay, ये थोड़ा difficult to understand, but idea वही है कि instead of having two separate things, you have it on one complete body now. Okay, and I actually do not remember from where I got this photograph also. इसका operation मेरे को भी याद नहीं है. But this is I remember it was a new modern solution that I have written that back pressure for room solenoid valve is basically together. That is the idea. So two temperature regulators and solenoid valve. ये temperature regulator है और ये आपका solenoid valve है. Back pressure regulation valve assembly. Okay. So basically both the things can be done. Solenoid valve can be also be in mid the same housing, and you can also have the back pressure housing the same in the separate in the same idea. This thing is second. Somewhere I had discussed with somebody this in a write-up method. कि इसका पूरा back pressure wall का I will just try to find out and I'll share it on the group or let's see what I can do. Yeah. Okay. Now,
सर ये मतलब can we say कि because you have different rooms and the temperature requirement for these different rooms are different, so for every required temperature there will be a corresponding saturation pressure of the refrigerant, right?
yes.
तो मतलब इसको ऐसे एक्सप्लेन कर सकते हैं कि लेट्स सी जैसे वेज रूम है, यू वांट टू मेंटेन 5 डिग्री फॉर दिस एग्जांपल, जैसे आपने जो स्लाइड शेयर किया है, तो इसमें लेट्स से टेक R12 फॉर एग्जांपल, तो उसमें इसका जो सैचुरेशन प्रेशर है इट इज हायर, राइट, 3.6 to 6, और
The other will be not be saturated in the other.
हाँ, तो अगर आपने बैक प्रेशर वाल्व नहीं लगाया corresponding to that particular saturation pressure, तो इसके अंदर वो प्रेशर मेंटेन होगा नहीं, because the other rooms are at a lower pressure, right? Then it will be difficult to maintain that temperature,
Temperature will
5
not
degree wala.
in the yes, because that flow will be basically going over here. ठीक है, ये saturation temperature
Right.
maintain. ठीक है.
So basically of all the rooms that you have, ठीक है, उसमें जो मैक्सिमम जिनके टेम्परेचर्स मेंटेन करने हैं यू विल रिक्वायर अ बैक प्रेशर, और मिनिमम जिस रूम का टेम्परेचर है यू माइट नॉट नीड इट, बिकॉज we need not have back pressure valves in all 3 rooms, right, sir?
No, only the one which is basically first
which is to be maintained at a higher temperature.
जैसे आपका हैंडलिंग रूम था और आपका वेज रूम था, उसमें दिखाया था उसमें, नॉट इन द
Right.
अगर फिश होगा और
मीट रूम में नहीं दिखाया था उसमें,
मीट रूम में नहीं है, मीट रूम में नहीं है
हाँ,
यहाँ.
so we can explain it this way, right?
Yeah, that's
केवल एक में रहेगा बैक प्रेशर वेल या ज्यादा यूनिट ज्यादा में भी हो सकता है?
Can you repeat, please? Anshul, repeat करें, please.
जो बैक प्रेशर वेल जो ये वेल दिया हुआ है, ये केवल एक ही रूम के लिए रहेगा या ज्यादा रूम के लिए हो सकता है?
यहाँ पे वेजिटेबल रूम है और हैंडलिंग रूम है, तो दोनों के आउटलेट पे ये है, बिकॉज दोनों सेपरेट टेम्परेचर पे होंगे. लाइक दिस मस्ट बी +5, दिस मस्ट बी +8 or 9. हैंडलिंग रूम इज एट आउटर एरिया जहाँ पे आपको डीप डीप फ्रॉस्टिंग के कुछ रखते हो या व्हाटएवर, ठीक है, फ्रूट्स रखते हो या समथिंग दैट वे व्हिच नीड टू बी एट अ लोअर टेम्परेचर, तो एट अ हायर टेम्परेचर, सॉरी. तो उसके अंदर भी बैक प्रेशर हो दिया, ठीक है. जितने भी आपके रूम है विच आर एट अ कंपैरेटिवली लोअर हायर टेम्परेचर देन द अदर रूम्स, उसके अंदर भी आएगा, ठीक है. समझे आप? means it not be only in vegetable, like you have got a handling room also here, तो उसमें भी दिया हो, ठीक है. पर जनरली हमारा सिर्फ एक वेज रूम होता है. हैंडलिंग रूम इज जस्ट द लॉबी ऑफ योर एंटायर वेज रूम ओनली, जनरली इन मोस्ट केसेस व्हिच आई हैव सीन. यहाँ पे लोगों ने एक सेपरेट रूम दिया हुआ है, सेपरेट इवेपोरेटर कॉइल के साथ में, तो वो दैट इज अ डिफरेंट आइडिया. बट जनरली दिस इज जस्ट जहाँ पे भी ये लोग defrost कर रहे हैं, कीपिंग द थिंग्स फॉर रेडी फॉर नेक्स्ट डे, नो, दैट इज जस्ट द लॉबी ऑफ योर वेज रूम, inside a separate compartment, obviously, because it is again not open to the outer atmosphere. तो उसके अंदर भी ये लोग ने दे दिया, ठीक है. I had seen one design also where there is no requirement for any back pressure, ठीक है. Why is that? Because they have kept a solenoid valve over here also, ठीक है. अगर यहाँ पे भी आप एक solenoid valve दे देते हो तो वो भी भाई बात वही होगा कि आप अगर आप टेम्परेचर solenoid valve दे दिया तो मैकेनिकल बैक प्रेशर को देने की जरूरत नहीं. So I have seen some systems, and I was a few months ago. I was having not few months ago, quite a few months ago. I was having a chat with somebody, and it turned a little bit aggressive. Like he was saying that तुम गलत बता रहे हो. I showed him that there are systems where there is no back pressure because there is a electronic solenoid valve given. ठीक है. Back pressure valve का तो older.
So in that case, वो सर तो in that case जो solenoid valve होगा that will be temperature controlled, right?
टेम्परेचर एग्जैक्ट. जैसे आपका रूम पे
okay.
टेम्परेचर आ गया, वो आपका इनलेट भी बंद कर रहा है, आउटलेट भी बंद कर रहा है, तो दोनों चीज कर रहा है. तो दोनों मतलब आइडिया वही है ना. यहाँ पे आप एक थर्मोस्टेटिकली कंट्रोल्ड चीज दे रहे हो which is controlled by the pressure, ठीक है, ठीक है. इंस्टेड ऑफ दैट यू वांट टू कंट्रोल बाय टेम्परेचर, तो थर्मिस्टर से कंट्रोल करके डायरेक्टली यहाँ पे अगर दे दिया, वो बात भी वही है, ठीक है.
तो इफ दे आस्क के मान लो कि अगर आपके ऐसे अलग अलग रूम्स हैं, मीट रूम, फिश रूम एंड वेज रूम, और वेज रूम में अगर बैक प्रेशर वाल्व नहीं दिया है और कोई भी अरेंजमेंट नहीं है, मान लो सोलेनॉइड भी नहीं है, तो इन दैट केस व्हाट विल हैपन इज कि वेजिटेबल रूम का जो टेम्परेचर है इट विल ड्रॉप मोर, 5 डिग्री पे नहीं रहेगा और कम हो जाएगा बेसिकली.
It will go below eventually.
Yes, yes.
Eventually. Eventually. Okay. And you
Okay, okay.
also get frosting at the veg room का जो evaporator, because उसका fan बंद होगा ना, तो वहाँ पे frosting भी हो सकता है, because fan
Right.
will be open, not be working at that time. But one more thing is there कि what I was seeing is I have seen systems where they have given a capillary design. Okay, instead of a back pressure valve, they have given a capillary tube, very thin tube. Okay, and the idea is that the systems are not too large in that case. That means bedroom, meet room are small rooms. Okay, not like your huge like for like for normal ship you have got not that larger rooms. ठीक है, छोटे छोटे रूम्स ही होते हैं, ठीक है, 20-22 लोग जहाँ पे, ठीक है. तो वहां पे बैक प्रेशर वॉल की जगह पे एक कैपिलरी ट्यूब दे दिया है, वेरी थिन ट्यूब, एंड दैट इज बेसिकली क्रिएटिंग द बैक प्रेशर. ठीक है, एज द आउटलेट गोज इट इज गोइंग टू कीप द प्रेशर इन द लाइन एंड नॉट अलाउ द, इट इज बेसिकली गोइंग टू थ्रॉटल द आउटलेट. ठीक है, मतलब ऑरिफिस तो नहीं है उसका, बट द लाइन इज वेरी स्मॉल. ठीक है, जैसा हमने देखा था ना कि थर्मोस्टेट एक्सपेंशन वॉल के अंदर भी कैपिलरी ट्यूब डिजाइन दिया हुआ है. ठीक है, सिमिलरली हियर आल्सो देयर इज अ फिक्स्ड ऑरिफिस ओवर देयर एंड देयर इज अ थिन ट्यूब आफ्टर इट. तो वो भी वही काम करेगा. So that will always give a pressure difference over here. It means only there to the main line. Main line में जब जाएगा that is the normal line which is there sticking the pressure that way. So but that will only work for a certain time. So that's why the temperature difference is not too much in that the room is not too much. The meat room बहुत बड़ा नहीं होगा, vegetable room भी बड़ा नहीं होगा. Like a smaller ship or something, like you have seen that type of design where you've got not a back pressure valve. So there are possible systems where you do not have, like in somebody shared the diagram of a provision refrigeration system of the ship where they don't have a back pressure line shown in that. But if you see uh, the this thing, no, what you call the legend of it. So legend में back pressure वाला दिखाया हुआ है. So most probably it mean that they are not shown it because it's a very small component in the line. ठीक है. Very physically होगा. I cannot confirm whether नहीं होगा, but वो somebody had showed it to me long back. एक line diagram where there was no back pressure or something like that. So I said something should be there in the line, no, to prevent the control. Okay. So I have seen the system जहाँ पे बैक प्रेशर नहीं है वहाँ पे सोलोनाइट वॉल्व दे दिया है टेम्परेचर में आइडिया वही है तो दो सोलोनाइट वॉल्व दे दिया इन एक आउट में वो चीज तो वही दे दिया टेम्पर दे दिया सॉरी नाउ इस तरह में राइट अप था ये जो सैचुरेशन प्रेशर है आप बोल रहे हो ना मेरे को अभी आ जाएगा सैचुरेशन प्रेशर एंड उसका जो टेम्परेचर के हिसाब से मैंने मैंने लिखा था क्लियर को भी मैंने आई रिटन इट शेयर्ड विद समबडी लॉन्ग बैक I just searched that and I put the answer in the group.
Yeah, when you showed that saturation temperature pressure now, so then I also remembered that I had read it somewhere. उससे then I could relate.
नहीं मेरे को याद नहीं आ रहा था because I did long back ठीक है definition मैंने almost मतलब I think about maybe 1 year or 1.5 year के बाद मैंने पकड़ा है वापस because I have other guys have been always been doing it ठीक है anyways so suction line accumulator क्या है ठीक है now see fitted in some larger refrigeration plants it consists of a vertical cylinder in the suction line between the evaporator outlet and the compressor its job is to protect the compressor from any liquid reaching its suction as this happens in the flow of the refrigerant goes on the top and is directed downwards. Outlet from the accumulator is also at the top. You see, outlet is on the top, inlet is also on the top. Okay. All that happens in the flow of the refrigerant goes to the top and is directed downwards. जैसे जाके ऊपर जाके वापस आता है. ठीक है. Now, therefore, the refrigerant vapor and possibly liquid has to change the direction rapidly inside the accumulator, and any liquid refrigerant will be flung out by centrifugal force. जो refrigerant है, तो वो ऐसे जाके जब नीचे आ रहा है, it will be flung out, ठीक है? And ends up in the bottom of the accumulator. मतलब वो जाके यहाँ पे लग जाएगा on the body, and it will fall down. So you don't want any liquid to go ahead, ठीक है? That is that. And the accumulator is not lagged, so the refrigerant will flash off into vapor because ambient heat from the surroundings and will continue towards the compressor. मतलब liquid आएगा तो जनरली क्या होता है ऐसा आके ऐसे जा रहा है और अगर liquid आ गया it will stay, hit the body and now it will flash off because ambient heat की वजह से and again it will go. Okay. The reason fitting the accumulator is to protect the compressor between the time that the expansion valve senses the liquid leaving the evaporator that the thermobulb and the expansion valve reacting to the reducing bulk refrigerant flow. जैसे वो ऑपरेशन चालू होता है और जब वो एक्सपांशन पर एक्चुअली मूव करता है ठीक है so at that time project करने के लिए because there can be some amount of liquid which is going along with the what you call towards the compressor okay so to prevent that you have got this suction line equipment so these are primarily used with large evaporators ठीक है so ये क्वेश्चन पूछा गया था somewhere I think it was asked by विजय यादव और पकरासी सर के what is preventing your liquid from reaching the accumulator the compressor suction ठीक है that is what is preventing it ठीक है तो ये suction line के अंदर रहता है and जनरली ये ऐसा एक पाइप जैसा लगता है तो people don't know also what it is ये उसका सेपरेट माइन डायग्राम में भी लिखा होगा पर जनरली इसके वो पेंट मार तो आपको समझेगा भी नहीं क्या है वो बट आइडिया क्या है गोइंग एट दिस एंड गोइंग आउटवर्ड तो अंदर कोई कॉइल वॉइल नहीं है जस्ट ओपन ठीक है तो आइडिया क्या है कि वो इट इज जस्ट गोइंग इनसाइड कमिंग आउट इज लाइक अ बिग ट्यूब ओनली एंड देयर आर टू इनलेट्स एंड आउटलेट्स तो चेंज द डायरेक्शन कर देता है
एंड दिस इज लाइक अ नॉकआउट ड्रम राइट
कम अगेन
सर this is like a knockout drum ना कि कोई भी liquid आया तो it will settle down and it will take the outlet only from the top of the space so that only vapors will come.
What is a knockout क्या?
हाँ मतलब basically it's a cylinder जिसमें आपका कोई भी liquid आएगा तो it will separate down and settle down और जो outlet इसका जा रहा है it is taken only from the top of the space.
नहीं see the flow of refrigerant is in at the top and is directed downwards तो ये नीचे इधर से ऊपर से आ रहा है यहाँ से आके नीचे जा रहा है and then as it is going up because there is no space to go it because centrifugal force is there is some bending happening over here the refrigerant is basically liquid will go and hit the walls and then when they hit the walls instantly it flashes off because of the heating which is there from the ambient surrounding and then basically it goes up so liquid sorry the vapor is coming and the suction line में आपका यहाँ पे जाके vapor जा रहा है so you don't want any liquid that is the reason is there
Okay.
flashing off immediately. Okay, that is the reason what it is preventing the liquid from reaching the accumulator. Accumulator क्या होगा? Accumulator is preventing the liquid from reaching the suction line to the compressor. ठीक है? So again, this has got its limitations. अगर ये बहुत ज्यादा आपका लिक्विड आ जाएगा तो इट विल नॉट बी एबल टू हैंडल बिकॉज इवेपोरेशन रेट तो एरिया तो छोटा ही है ना इसका इन कंपेयर विद द एंटायर दिस थिंग इट इज हैविंग अ वेरी स्मॉल एरिया इन कंपेयर विद द एंटायर evaporator and the lines. So if there is lot of liquid coming, then it will not be able to handle it. Okay. So little about basically कब है जब expansion valve sense कर रहा है liquid evaporator and the bulb starts closing. So at that time, some liquid can still move across the evaporator, okay, across the TX2. So that is the reason it basically at that time it is sensing it and it is removing that whatever is the gas there. It is not allowing the liquid to reach the suction line. Okay, I think this we have done. No, we evaporator need. Okay. Now evaporator. These normally consist of a fan circulating air or the fin tubes through which the refrigerant is flowing, thus cooling the air down. Basically, air को ठंडा कर देता है, which is then circulated around the cold. They will include a method of heating to minimize ice and frost buildup on the tubes and fins. This defrost system will be timed to switch on periodically according to the rate buildup from the ice and frost and ice, normally 2 to 3 times a day. We will talk about methods to defrost the system, जिसमें hot gas defrosting भी कल बात करते हैं and other methods also. Off cycle, on cycle का भी बात करेंगे. Okay. So 2 to 3 times it will basically defrost. This to a large part will depend upon number of the time the cool room door is opened, allowing warm moisture to enter the room. तो अगर ज्यादा टाइम आपने खोल दिया है तो डिफ्रॉस्टिंग ज्यादा करना पड़ेगा, ठीक है? तो आपका इवेपोरेटर के ऊपर जाके कंडेंसेशन हो जाएगा. So drip trays are fitted below the evaporator to catch the melted frost ice during the defrosting. The drip tray should also be fitted with the heaters as well as the drains to ensure that they do not ice up and block during the normal operation. This is a very common thing, like your icing up happens at your evaporator because your drip tray का जो drain है वो choke हो जाता है. तो अगर वो water वहाँ पे रह के क्या होता है, water will basically start basically icing up over there, and then slowly the entire evaporator will basically get iced up. And when the evaporator gets iced up, then obviously your heat exchange will basically suffer from it. Some large plants, some refrigerated lorries and containers may have what is called a reverse cycle or hot gas defrost. But ये हमारे ships से भी होता है. We'll talk about this tomorrow when we see the entire system. Here automatic three-way valves are there reversing the refrigerant circuit. इसका डायग्राम भी आता है, वो समझाऊंगा ना तो आपको बेटर समझेगा कि वो कैसे hot gas defrosting कहाँ से होता है and how it works and everything. You'll see that. Hot gas defrosting was also used for a type of capacity control also. मतलब उसका it can also control the capacity in that method also, but not that much. Can also doing that also because you are basically short circuiting the entire circuit also. They may also consider blocks of basically brine system के बारे में बात कर रहे हैं, not important. So this is the entire way. See, either the refrigerant is going here and the air is going perpendicular, or you've got a refrigerant going parallel and you've got basically more finned coils and the air is going perpendicular, or you've got a refrigerant going through the entire plates. ये आपका system होता है in your big reefer ships. Like one of my reefer ships has got this like this, like air basically refrigerant going through and air basically being circulated from top. And you've got air blowers on top, basically they're blowing the air across the refrigerant column, refrigerant coils. So refrigerant coil is going in a helical form like this, not helical, spiral form, and helical form only, and it goes out from this, and on top you've got the aircraft blowers. They're basically blowing the cold air inside the room. Okay. Last thing is the shaft seal. A mechanical shaft seal is fitted to the crankshaft on the drive end of the compressor. It prevents leakage of the compressor in gases to the atmosphere. The free end of the crankshaft is filled with a plain cover plate like this. Okay. Now, thermostat. Primary control of the refrigerator space is by individually room thermostats. These open and close solenoid valves, thus allowing the liquid refrigerant to appropriate expansion valve. And expansion valve के भी काम करते हैं, as well as आपका जो solenoid valve को भी control करते हैं. Hence, the appropriate evaporator is operating at a proper time. Small domestic units with a single refrigerated space will often start and stop the compressor. The thermostat should be set with a sufficient differential difference in the temperature between the opening and closing of the solenoid valve to avoid the solenoid valve from opening and closing too frequently. Means you don't want it to short cycle. मतलब वरना आपका जो setting गलत है. For example, the optimum temperature of the refrigerant space is minus 20 degrees Celsius. It will be usual to set the thermostat to open at solenoid at minus 18, the temperature rising, and close solenoid valve at minus 22. Then temperature starts falling. Okay. This is the idea. तो ये thermostat को भी आपको regulate करना चाहिए. कि ज़्यादा कर दिया तो short cycle हो सकता है. तो वो इस टाइप से. Large cold stores and some air conditioning systems, including marine installations, with more than one evaporator will often arrange the thermostat controls to operate in a cascade, thus bringing the additional evaporators as required according to temperature difference. means अगर आपको requirement है तो और additional evaporators को भी system में ला सकते हैं. Cascading system means as one fails, other one takes over, and it is basically going over and over that. Some transfer refrigerant with engine-driven refrigerant compressors not important. Evaporator fans may also be arranged to stop and start, controlled by thermostats, but will normally be left running continuously. Some plants are arranged with door switch, which will open and close the appropriate solenoid valve and stop the evaporator fans when the room doors are open. That is also important. अच्छा, अभी pressure controls बाकी है, and we'll talk about the safeties, like your differential oil pressure controller, high pressure cutout, low pressure cutout, and that is remaining. And then we'll start with different things like charging of refrigerant, different methods of charging, and then we'll see the different circuits. Okay, कैसा होता है, and that will progress as well. Okay, चलो guys, let's end over here. All right, and we'll meet again tomorrow, guys. Okay, good night, guys.
Good night.
Good night.
Good night, sir.